Okay, let's take a look at inverse nth power variation. So here we have a function and it's inversely proportional. That's k over x, but this time x has a power on it. Or we could say y is equal to our constant over x to a power. So again, we're going to know to set this up or use these equations in the problem. It's going to somehow tell us that. So here it says light intensity is inversely proportional to the square of the distance from the bulb. So you have a light bulb, right? And how intense that light is inversely proportional to the square of the distance you are from the bulb. Now it gives us that at 18 feet, a bulb has an intensity of 90 watts per foot squared. What is the intensity at 36 feet? So we're going to double the distance, right? From 18, we're going to go to 36 feet, but we're going to see that the intensity doesn't get cut in half, okay? Because it's inversely proportional to the square of the distance. All right, so now let me write down my equation. Let's see, the intensity is inversely proportional to the square of the distance, right? The intensity of the bulb is inversely proportional, so I put k over the distance squared, or the square of the distance. Now I want to try and find k. I'm given that at 18 feet, that's my distance, I've got 90 watts per foot squared, that's my intensity. So I can write 90 equals k over 18 squared. Now what I do is I put 90 equals k over, now 18 squared on your calculator, 324, and now multiply both sides by 324. 29,160. This is our constant of variation. Now we can use that information to answer the question that they're asking. That's what is the intensity at 36 feet. So here intensity is what we want, right? We want to know what I is, and we're given this is d, our distance. Now what we can do is we can go back to the original equation. We can now determine that the intensity will always be our constant 29,160 over our distance squared. We will replace our distance with 36. So the intensity is 29,160 over 36 squared. And let's see what happens there when we square 36. We get 1296. So now we have that the intensity is equal to 29,160 over 1296. Is that what I had? Yep, 1296. And then I just compute that. I get 22.5. So 22.5 watts per foot squared. So you can see that by doubling our distance, our original, our intensity went from 90 down to 22.5, so it didn't get cut in half. And that's because it was inversely proportional, but to the square of the distance. So that's the answer.